says, the diagram at the right portrays a Hot Wheels track designed for a fun physics lab. The car starts at point A, descends the hill, continually speeding up from A to B. After a short straight section of track, the car rounds the curve and finishes run at point C. The car continuously slows down from point B to point C. Use the information to complete the following table. I use the directions east and west. You could also use the directions right and left, just looking at the picture. If you think about what's actually happening, it would be like going down and then straight and then curving. Those directions are very helpful because we need to have like consistent directions in one way or the other. So if we say east and west, at point X, what would the direction of the velocity vector be? East, and what would the direction of the acceleration vector be? East also, yes. Because it's speeding up, and so when it's speeding up, the acceleration vector will go in the same direction as the velocity vector. Okay, then point Y would be, the velocity vector would be what?
East.
East, yes, and then the acceleration vector would be west, because it tells you that it's continuously slowing down from B to C. So point Z, what would the velocity direction be? West, and the acceleration vector would be east, right. Okay, and where it says reason, the reason for the velocity is always that it moves, that's the direction that the car is moving. And how would you describe the reason for the acceleration vectors?
Speeding up or slowing
If it's speeding up or slowing down, yes. So if it's speeding up, it's going in the same direction. If it's slowing down, then it's going in the opposite direction. Okay? Any other questions about your acceleration assignment? No? Okay, how were those review questions? Good? Did you guys have time to talk about them with each other? No? Okay. Why don't you discuss, and then we will go over them together. Okay?
Hey Skylar, did you do it?
What?
Did you do it? Do you wanna review it? 'Cause mine
Sure.
isn't. Okay. Did you get vector for one? Scalar, vector, scalar, scalar, vector.
Yeah.
A, okay, A, B, C, AC.
I only got C for number 10, you can only pick one.
It says circle the correct answers on the top. What did you guys get for number 10? Did you get A and C?
I just got C.
Yeah, that's what I got.
Wait, why did you just get C?
So you can only pick one.
But it says circle the correct answers with the S and like.
Wait, what'd you get?
I
Where
got
does
A
it
and
say
C.
that?
No, number.
Yeah, it says it right here.
Yeah.
That applies to all of them.
Okay.
Cause how would you be
Oh,
able
right
to
there.
circle all of 9? Like for number 9?
But
It said select.
select all that upon.
I didn't read the thing out there.
Maybe I didn't know. Okay, well 11. G.
I got D.
Yeah.
12,
B.
It said
I
constant
see.
Oh, you got C.
Yeah, because
Since
in our,
acceleration
if
is
you look
like a
at the
change in
definition in our
velocity,
notes of
it didn't have any,
displacement,
but I'm not
it's
sure.
how
Maybe I'll
far
just ask
out
her
the
to explain
space,
that, 'cause that makes sense.
which the object's
Maybe
in.
that's-
Oh,
I got confused on
Did you get 12M
What?
for 13?
I got, yeah, A.
Okay. No, I got 12. How'd you get A?
Because they didn't move. Like
Oh,
this,
they
it's
just went
this-
like that way.
Yeah, it just made a
Okay.
rectangle,
That makes sense.
so the displacement is 0.
Yeah. B.
Yeah.
I would have a
I got-
question
I
on
got
fish.
Oh, we got this.
Trying to figure that out, but I did not get any answer.
Okay, we can skip that one, then we can come back.
Yeah. You get D,
I think the only
D.
reason
Yep.
I crossed
C.
out,
Yep.
A,
Yep.
D,
speed was cause it
B.
was like
Yep.
2, then
C
4,
and
then
D.
6, then
Yep.
8. The acceleration,
C.
I thought like every time.
I got A, C, and B.
I think that means
Because, the velocity is changing speed and direction, so then I thought it could be
2
one
meters
or
per
the
second,
other.
and another 2 meters per second.
Yeah, I'll ask the
Four,
question.
that's like altogether 4, so like 2
Yeah.
forward.
I didn't get 24, I was not.
I got A, B, and B.
Okay, 25.
It's like, cause
C
same
and
for
D,
each,
or
it's
A,
like
C,
each
D.
second. Like,
Oh,
if
yeah,
it was
but-
saying it moved 2 meters,
C.
and then it moved 4 meters, then it moved
I
2
got
meters,
A.
and then it moved another 4 meters.
Yeah,
and then
okay,
another
that's what I was
6.
How'd you get A?
27, I don't know if I just, because I'm more good than that. But I do. Yeah.
Because,
Speed
wait, what
also
did you
has
get?
that, like,
I got
another
C.
one. Yeah. And then this one, it wasn't in video.
Because it's just changing and, it's just, it has a constant speed, but
No, it's just changing its speed, because it's going from 2 to 4 to 6 to.
that's like, this is meters, that's not its speed. The second is its speed. 2 meters, 4 meters, that's like the distance.
But it says meters per second.
I'm just.
I know, per 1 second, the second would be this, the time, or, I don't know, maybe I'm wrong. That's what me and Lauren got, but I can be wrong.
Do you get D?
I got D and, C.
The only reason, because I know like it was changed.
Cause you-
Oh, yeah, I got
You
C
had to like
too.
subtract the first one.
B.
The last one.
Yeah.
A.
This one only gave 1, that's
Can
what
you
I
get
meant.
B?
Wait, use the first one minus this one.
What?
Like,
BE for number
it's like
30,
changing
like it's
velocity
like a
over
B and an E.
time to
No,
get
I got C.
acceleration. So you had to subtract like the final.
How'd you get
velocity
3?
Minus the first.
Because it's just talking about the displacement between A and B.
Oh. Stupid. That makes sense. Anyway, okay, cool.
Oh, here we go. Oh, yeah. Oh, yeah, it's the change of velocity. And since that one only gave velocity, it means it has a constant velocity, which will change. So, did you get it for a nine?
Well, we got D.
Okay. Easier. We got the same things we did together. Oh, that's not.
For what?
We're trying to figure out which one we want.
I got
Why
B.
isn't it screwed?
I just thought since it said, cause like constant for, we found the acceleration, which is, right, it's the change of velocity over time, but it says it has a constant velocity, so like the change of velocity would be.
So the change would be 0, so then it'd be.
0 over 10 would be 0.
No, like the,
I thought it was
Zero.
distance over time.
like, cause if you do, the other
Isn't that what
one,
it
like
is?
this one,
Distance over
if you
time
do like
is-
the final minus the, like, original
Acceleration
one,
is change of
then you'd have
velocity.
20 minus 0, which is just 20. Cause it changes.
Okay, so we did it over and.
I got 2.
Or the final and original are the same, so then.
That's why I'm confused.
Oh. Yeah, then it would be
know.
0.
Wait, how are the finals?
Because it didn't change, so the original
you have to
speed
put-
and the final speed are the same thing.
should
it's
look at
supposed to be like
the
changing.
definition for velocity, because I get confused. So it's the
But
rate that an object changes position.
That
So
would make
the-
sense
so
that
the
it'd be
rate-
zero though.
The rate that is changing position is tense. Or is it not, it's not even changing its position? Like, I don't
It's,
know.
okay,
I
it
could be
says
wrong.
constant velocity 20 meters per second east for 10 seconds. So it's accelerating, so to be accelerating, it would either have to change direction, speed up, or slow down, right?
Do we have a definition for constant velocity?
So even, I don't remember. I think they're,
No, there's constant acceleration, not constant velocity.
What?
Velocity is
I got
the rate at which an object
CMD.
changes
Or
position.
CMD.
Speed of the direction, but it's not
CMD.
changing position.
Circle both.
select all
So
of them.
I don't even get how to use velocity.
Oh,
Why
20,
isn't it-
never
why isn't
mind.
it just acceleration?
I got
Why is it
D.
velocity? Or would it just be cars moving at a constant acceleration of 20 meters per second?
I always remember acceleration has velocity in it because
Right.
it's always the speed and direction.
Right.
Because it's
the
either
rate at which
slowing-
something
slowing
changes
up.
position, so
Speeding up.
or slowing
Or
down.
slowing down,
changes
or changing
position, so I don't
direction.
know if it'd be
Right.
like- I don't know. But then also it's like the final, sometimes the initial, I mean, if it's talking about how much it moved, then it still would be 20.
I'm confused on number 21 now.
Minus,
I thought I had it right.
zero, then it'd be 20 still, so, yeah. Ms. Faulkner,
Yes.
could you please help us on number 21?
Yes. What do you guys think it is?
I think we were
Two.
kind of confused as to if you do like 20 over 10, like you divide 20 by 10 and get 2, or if it's like 0 divided by 10, which is 0, because we were trying to think, did the velocity change, like would it still just be 0, or did the velocity actually change to like 20, and like,
Does the velocity change?
It's moving.
well, it's not changing direction.
It says constant velocity.
So then when
So if it's constant, that means not changing. So if the velocity is not changing, what's the acceleration? Zero.
Yes. The
So it'd be A.
acceleration is the changing velocity.
But could you still like do like, cause it's technically like 0 divided by 10, which is how you get like the 0.
Yeah.
Okay.
Ms. Faulkner,
Yes.
could you explain number 23 to me?
That's another question too.
Okay. If an object has an acceleration, then it must be. So what does it have to be doing if it's accelerating?
Changing its velocity?
It has to be changing its velocity, so it has to be C. And that would be the only one. It says select all that apply. It can be changing its direction. It can be changing its speed, but it doesn't have to be. It doesn't have to be changing its direction or its speed. So it would only be C for number 23. Yes.
Isn't velocity like the rate at which it changes direction, so it has to be changing direction?
The velocity is it's basically speed with direction. So velocity could either be speed or it could be direction.
So then it'd have to be changing its speed at least? Cause like if you have a
It
constant
could only change its
speed-
direction. So velocity, so for acceleration, it could only be changing its direction because that means the velocity is changing even if it's going the same speed. Or it could be going the same direction and change speed. There's three things that it could be doing if it's accelerating. It could either be going faster, it could be going slower, or it could be
Changing its direction.
changing its direction.
Can you explain number 24?
24, that one I think was actually on your, I think that same question was on your acceleration worksheet yesterday. what did you guys think? An object that is not accelerating must, what?
You maintain your constant velocity.
Right, D. And I think we talked, that one does say select all that apply. You could argue A, that it would be at rest, but it doesn't have to be at rest. So it would most accurately just be D, because it doesn't, because where it says it must, so it doesn't have to be at rest, but it could be at rest, just like for number 23, it could be changing its direction, or it could be changing its speed, but it doesn't have to be. Yes. Olivia?
Is the reason that B, like be moving and moving with a constant speed, is the reason that doesn't work is because it could be changing its direction?
Right.
Okay, so even if it's not speeding up or slowing down, if it's moving back and forth, that's still accelerating?
Yes.
Okay.
Okay.
Could you also review number 15? 'Cause I like.
Sorry, what did you say?
Number 15.
15, you're just looking at his overall displacement, so you're just looking at where he starts, which is at A, and where he ends up, which is at E. So, and seeing what the displacement is of that. So from A to E is 20 yards, and it would be going west, so that would be B. I'm just gonna quick read through the answers, so you guys can check, and then if you have any other questions on that, let me know.
Is this how the text is gonna be?
It'll be similar, yes. Okay, so the first 6 identify the following as being either a scalar or a vector. Number 1, vector. Number 2, scalar. Number 3, vector. Number 4, scalar. Number 5, scalar. Number 6, vector. Questions on any of those? No? Okay, 7 is A. 8 is A. 9 is A, C, and E. 10 is C. 11 is D.
One question.
Yes?
Can 10 not be also A?
Distance has a direction and displacement has no direction. Those are opposites. Distance has no direction and displacement has a direction.
Okay.
Okay? 11 is D. 12 is C. 13 is A. 14 is B. 15 is B. 16 is D. 17 is D. 18 is C. 19 is A. 20 is D. 21 is A. 22 is C and D. 23 is C. 24 is D. 25 is A, C, and E. 26 is B. 27 is D.
Can you explain 2016?
Yes. A car's velocity after each consecutive second of motion is 2 meters per second, 4 meters per second, 6 meters per second, and 8 meters per second. This is evidence that the car is, and we're choosing between moving with a constant speed, velocity, or acceleration. So those are speeds that are given to you, or velocities. They actually don't tell you the direction, so but they say that it's the car's velocity. So the speed and the velocity are both changing because it's going from 2 to 4 to 6 to 8. Those are the speeds and also the velocities. So it cannot be A or C. cause those say constant. If it's constant speed, that means the speed would be staying the same for every second. So it is moving with the constant acceleration because every second it goes up by the same amount of meters per second. Did I explain that well?
A little bit. Well, I guess because I was like, I'm thinking the constant velocity because it's like, like still going in that direction. And it's like 2 meters per second for every like second that it's going, right?
They're telling you what the velocity is for every second. So they're saying like in the first second, the car is going 2 meters per second. In the second, it's going 4 meters per second. So that means that the velocity is changing every second. It's going up by 2.
And
What would the definition be for constant velocity?
Constant velocity would be very similar to constant speed. It's going the same speed in the same, it's maintaining the same speed in the same direction.
It says moving at the constant acceleration though, I think, and that's confused me because doesn't constant mean not changing, the acceleration has to be speeding up or slowing down.
But the acceleration is the amount at which it speeds up or slows down, right? So it is going up by 2 meters per second every second. That's why the acceleration is constant, because the amount that it's changing by is the same. Because acceleration is how much it changes, right? Or the changing velocity. So it's changing by the same amount every time. Every second it's going up by 2 meters per second, which means that the acceleration is maintaining, it's staying constant.
Oh, is that because it's going up 2 each time?
Right.
Okay.
Like if it went 2 meters per second, 4 meters per second, 8 meters per second, 12 meters per second, then none of them would be constant. The acceleration would not be, neither would the speed or the velocity. Is it making more sense?
Yeah, I think I'm just confused then because I feel like, well, wouldn't it just be going one speed then if it's moving up by the same? Like, how would it be speeding up then?
Let's like make a. Okay, so we have time and we have velocity and we have acceleration. Can you guys see that color? Okay, so at 1 second, the velocity is 2 meters per second. So let's start with 0. At time 0, and then we have 1, 2, 3. Okay, and then we have at 1 second, it's 2 meters per second, and then 4 meters per second, and then 6 meters per second, and then 8 meters per second. Remember, velocity is speed with direction, and they actually don't tell you the direction, so that can be confusing there. But we're likening that to speed. So the speed that you're going, or the velocity, is changing every second, right? The acceleration is by how much it's changing. So from 0 to 1 second, it changes how much?
2.
2 meters per second, because it's changing 2 meters per second in the first second. And then 2 to 4 changes by how much? 2 meters per second, and then 4 to 6, 2 meters per second, and then 6 to 8, 2. Okay, so do you see how the acceleration then is constant? but the speed and the velocity is not, it's different. Does that help? Lauren?
Yeah, it helps. I think I just get too stuck on the definition because I think acceleration has to be speeding up or slowing down, so how can it be acceleration?
Well, it is speeding up, right? If you look at the speed, it's going faster and faster, right? So it is speeding up, but the actual number value for acceleration is how much it speeds up every second, or every minute,
Okay.
or for every unit of time,
That makes more sense.
okay?
So if you were to put this in an equation, how would you set that up? Could it go into that one equation where it's like trying to figure out the acceleration?
The acceleration equation is what? Final velocity minus initial velocity. That would be if we were finding the average acceleration.
Okay.
Yes, so you would do 8 minus 2 divided by 4 minutes, right? So 8 minus 2, or 8 minus 0, which would be 8 divided by 4 minutes, so which would be 2.
Okay.
So since they are all the same, that would be the same as the average acceleration. Okay? Alright, 27 was D, 28 was B. Which one?
27.
27.
Because I thought it had to be the second.
No, it does not. Acceleration just has to have through basically 2 units of time. 28 is B, 29 is A, and 30 is C. Okay, any other questions about that? Olivia?
For the test tomorrow, with like the definitions or the equations, do we need to memorize those or will it kind of be multiple choice like this?
It will either be multiple choice or matching,
Okay.
so you won't have to write them out. No.
Okay.
It's mostly like making sure that you understand and being able to apply it, just like this. Okay. Other questions? No? Okay. Very good.
What are you doing? Shopping or expenses?
There we go.
Chops.
I love chops.
Just like an expensive restaurant.
That's like it.
It's kind of like Eddie Merlot's.
It's so good. It's
Why
not as
do I do
expensive
chops?
as
Yeah, it's my brother's birthday today.
Actually, Eddie Merlot's, I was very surprised, they're really not that expensive.
No, they're not.
Like,
I
he just
went
took
there for my
forever.
birthday,
And
Neither
it's
is
cheaper.
Biaggi's. Like people think Biaggi's
Well,
is
yeah.
expensive.
And
I think
honestly-
Biaggi's is pretty expensive.
Yeah, but like.
Well,
Wait, so
I mean, you guys have like a family of like.
That's expensive.
You
It's
guys
like
have
the
like a
upgrade
family of
classes.
5.
Well, yeah, you don't wanna like take a family there because it's like.
Biaggi's is a copycat of Maggiano's. Which is like, it's like they're exactly the same. They have their whole like cheese station.
I think honestly, like, if you
Why
go
do
to
you
an
think
expensive
that's
restaurant, it
really
won't be that expensive if you're taking like 2 people. It'll be fine.
Have you ever been to Rosebud? That's a good Italian restaurant. I love that place.
So I made a face at Wolfie.
Oh.
He made a face at me, so I made a face at him.
Hey, guys, maybe you can help me figure this out. My flip flop broke. So should I just like walk around barefoot?
Say hi to Lauren. You're like, my flip flop broke, and I had the camera right on you.
Would tape aid assistance to you?
You could use jet glue, Marnie.
Yeah.
No, that's gonna like
No,
melt
that's
it.
gonna
Doesn't
melt
make it like
it, yeah.
smoke.
Right.
Oh, just kidding.
Well,
This is fun.
What are you doing?
happy
Is
wasting
it Wednesday?